Hi, this is Harish here. Welcome back to DB2 LUW tips and tricks video tutorial. In this tutorial, we are going to talk about spectrum scale cluster. Specifically, the tip is about how to create and delete spectrum scale cluster. The scripts that I'm using, the data files that I'm using are available for free download at db2luwacademy.blogspot.com. Please subscribe to my YouTube channel, youtube.com/db2luwacademy. This is the problem scenario slide. So the scenario is GPFS, General Parallel File System. IBM GPFS has been renamed as IBM Spectrum Scale Developer Edition. If you have seen my previous video on how to install Spectrum Scale, I would have said the same thing. And this particular video is for educational purpose. It is not something that you find in the field, like it's not in the field out there. So people, when I say I'm going to demonstrate how to create and delete GPFS spectrum scale cluster, the creation and deletion, I'm just going to give a demonstration of what are the commands used and how to create the cluster and all that. And we'll be creating the cluster, but the configuration varies. So in the field, in the real-time servers or in the real-time applications, the kind of configuration will be a little bit different because there are many cluster configurations and they are like as per your need. So if you understand the GPFS system, it is like a network of disks that you create over which the file system exists. And there is a concept like you can have, usually they go with shared disk. So because it's a general parallel file system, right? So multiple servers or nodes will have access to read and write data to a network of disks. Okay, so that is the concept. So there are like mix and match of configurations like that. Many variations are possible. So I cannot go and demonstrate each variation. So this tutorial is just for beginners and who are intimidated by the commands and things like that to do the things. So this is going to be just a kickstart, or it's going to be like, you know, to remove the fear out of the commands. Okay, that's the whole idea. And in this specific example, so we'll be having a 2-node cluster with one node behaving as a quorum node, which is also the server node. So the server node will be having the disks that needs to be provisioned, and the client node will be accessing the disks, and there will be no shared disk between the server node and the client node. So there, like, the disks are physically attached to the server node, and you can also have configurations with shared disk. So in which case, you know, if there are 2 nodes in the cluster, or even 4 nodes in the cluster, 5 nodes in the cluster, all the nodes will have access to the same set of disks, or it can be an individual disk also. So that's what I'm saying. So there are multiple configurations. So I'm just taken the simplest configuration, and this will not even have any tiebreaker disks in the cluster. So there is no tiebreaker disk. Again, if there is a tiebreaker disk, it has to be a shared disk. So we are not getting into those kind of things. Okay, and further information like you can find in Knowledge Center, obviously, if you want to deep dive. So ibm.com/docs/en spectrum scale 5.1.0 is available. I think later versions is also available, I'm not sure. And you can also download the free developer edition. And again, the URL I have given, it's ibm.com/products/spectrum scale. Okay, so that's it in this. This is what we are going to see. That's it in the slide. So let's jump into the examples. So I'll show you the server. So this is one VMware workstation. Like this is one OS, like one machine, virtual machine. This really has only one hard disk. So this is elementary OS. So this will be behaving as Linux. This Linux will be behaving as a client node, and there is another server Ubuntu, so which is running the Ubuntu software, Ubuntu OS. So this will be another machine. So this will be like on the client. This will be the server node, to which you will see there are multiple disks attached. So there is this disk is 20 GB, which is the OS disk on which the OS is running. Ubuntu is installed, and the next disk is 15 GB. It is a free disk. This 15 GB is also a free disk, and this 5 GB I have just kept it like it's not going to get used. So this is just, so this machine is the one containing all the disks. Okay, we can see that here also. For example, like so this is in the GPFS. So I'm going to say f disk -l. So you can see I am in the GPFS 1 system. This is the Ubuntu system, and I'll just show you that. So you can see here, this workstation is okay. IPA. So this you can see 119, which is the same as this guy. Okay. So I'm connected to that same machine 119. You can see that the machine name is GPFS1. I don't know why I named like that, but that is the machine name. Okay. So both of these, first thing is obviously you need to install Spectrum Scale on both the systems. So you can look at the previous video on how to install that. So I've installed that, and the location is this path user lpp mmfs bin, and this is Ubuntu system, and this is the another elementary system. So this also has the same path. So I can show you. This is a different IP address 124. Okay. Now if I look at ./mmls cluster. So these nodes, they do not belong to any cluster. So you can see that as of now they do not belong to any cluster. And I'll also show you fdisk -l. So you can see that there is a 5 GB disk. This is not, we are not going to use it. So this SDB is 15 GB, SDC is 15 GB. These two are the 15 GB raw blank disks that we'll probably use. We are going to use. Okay. Similarly, in element system, if you look at, this doesn't have any disks apart from the OS disk. Okay, so SDA is there 17 GB, which contains the OS and the swap. So this partition is the root partition, which contains the elementary OS, and this is the swap space partition. So this contains only one disk. It doesn't contain any other disk. You can see nothing is mounted also. Okay, so we are going to mount the GPFS file system. So first we need to create cluster for that. So I'll go to the video here. Okay, so mmls cluster, that command we have run. So this is the command to create the cluster. So mmcr cluster, we are giving the cluster a name, and this is I think UID, and this is the cluster name. I think it would be called, I don't know, scale.spectrum or spectrum.scale, I don't know. Let's see. Okay. So this is some name, and these are the nodes. So GPFS1 is one of the node, and elements, that is the machine name. So that is another node, and this node, GPFS1 node, will behave as the quorum node, and the other two will be like a manager node. So I'll be able to manage the cluster from these two nodes. Okay. And okay, let's just go run that. So this is the first cluster command, cluster creation command. Okay. So I'll run it on the server node only. Okay. Basically, you can run it from anywhere actually, but I'm just preferring to run it on the server node. Okay. So let's see what is. So after creation of the cluster, you have to accept the license, okay, for the usage purposes. So we'll also do that. Okay. This itself is taking a long time. Okay. So you'll have to accept the license. Okay, it's all done. Okay, then we'll yeah, we can just look at the license information. So if you want, so like that. Okay, so number of nodes defined in the cluster 2, number of nodes with server license designation 2. So two things are in, the license is accepted. So we'll again run the like if you want to know what is the cluster information and all that. So you can see that this node acts as the quorum node, and it is also a manager node, and this node is the another. So these two are two different machines, as I showed you the IP addresses and their host names and manager. So both of these nodes can be used for managing the cluster, and you can see scale.gpfs1. So that is the GPFS cluster name, and the GPFS UID domain is the spectrum. So if you remember, like, see, this is the UID domain name that we have given, and this is the cluster name. Cluster name and UID domain name. Okay, those two are the things that we are providing in this command. Okay, so now the ls cluster is done. Now we can get the state of the cluster. So whether it is up or down, like that, if you want to understand that, you can get that as well. So -a means all the nodes. So if you just, so as of now it's down. So if you don't give that -a, it is just going to show the status at that particular node. So you can run that command here also. So for example, like that. So it will say down, and if I say -a, it's going to pick up the status of both the nodes which are part of that cluster. Okay, so you can pretty much run the same thing, mmls cluster from here also. So because this is also part of the cluster node, and this is also part like a manager node, right? Elements is a manager node, so you should be able to do all the things. Okay, you should be able to manage the cluster basically. Okay, so now we have created the cluster. Yes, it was as simple as that. And next is we need to create something called as NSD, which is like, see, we had those two disks of 15 GB size, right? So I have given the device SDB and I have given device SDC. Okay, and NSD is the, so one disk is for data purposes and another disk is for metadata purposes, and this will be the server GPFS1. So this is what I said, this will be the server node. Okay, and the usage is data only, and this usage, so in SDB, which is of capacity 15 GB, we are going to store only the data, whereas the SDC, which is also containing 15 GB of size, but it will contain only metadata. Okay, so like this we have to create a file which is like root NSD stanza. So I have already, I think I have already created that file, so I'll just show you that information here. Okay, yep, so device SDB is there, SDC is there, data NSD, meta NSD, that's the name of the network device, network disk. Okay, so the command to once I do that, the command to create the NSD, or I don't know what should we call, like it's a network shared disk or something. I think so, it's a network shared disk. So let's run that. So this is, so we need to have that file in that location, which is already we have seen. And the way this is configured is two disks, one disk will be holding the data, another disk will be holding the metadata. Both the disks are attached to the system, like there's no disk here, so you can see that there is no disk here, SDB, SDC, nothing is there, right? Only this guy, like in this system you will have this is a server node, we have SDD, SDB, SDC, everything. Okay, so now we are going to create the okay, before even creation you can even probably like LSNSD. So are there any disks? No, there are no disks, so you can go ahead and create. Okay, so it will refer to that NSD stanza disk, so you can see that processing disk SDB, SDC, and it is propagating the changes, blah blah blah. So that's done, and you can run the LSNSD again. Okay, so now you can see two free disks are there, data NSD and meta NSD, and the same information should be available on the the client node as well. Okay, but even though this is a client node, we can manage the cluster from here also, so we are able to see the disks. So once the disk is in place, we can just go ahead and create the file system. But before we create the file system, it is better to start up the node. Okay, so we'll start up the node. Okay, that's the command for starting up the node. Okay, oh, I have started in elementary, so I need to start the node in this both it's better to do it in both places, but eventually we will be doing it in both the places. So once you start up, you can say get state -a. So you should be able to see the state as arbitrating, and it should eventually become active. Okay, so now the GPFS is up and running. So for creation of disk, you don't need to have the GPFS background services running, but I think for the creation of the file system, you need to have the GPFS system running. Okay, background in the daemons. So we have started up the node, and we have listed the network shared disks also, so you can see that. So the disks are there, the GPFS state is up and running. So now you can go ahead and create the file system. The command is mmcrfs, the location in which you want to create the file system, and the same file, the root NSD stanza that we used, we are going to give the same thing. Okay, so this will create the file system. So the file system will be on both these disks, like the data NSD and the meta NSD. Okay, all done. Okay, and then you can even list, if you want to understand and you want to list the properties of the file system and try to figure out what is that, like you can always do that using the command mmlsfs. So you can see that this is the default mount point, this is the block size, and like what is the block, see, minimum fragment, sub block size, index node size, indirect block size. Like if you want to change any of these parameters, you can change. And there is also a location like mount point, so there is a default mount point that is that it is assigned. And you can see it contains two disks. This file system contains two disks, data NSD and meta NSD. So you can see that very clearly here. So these are the properties of the file system. And okay, so once we see that, let's see df. Okay, you see that it is not mounted, right? So you can manually mount it using this command. Okay, let's just do that. So this is on the server node. I'm mounting the file system. So when I say df, so you can see that it is mounted, but on the client node it is not mounted, right? So either I can use the mount command, or I can just shut down and start up my GPFS background process. So on the client node, what I'll do is I'll just shut down the background process. And I'm going to just start it up again. So when I do that, it should actually automatically mount the file system. Okay, so I'll just start up the GPFS daemon, and okay, I don't see that. Okay, yeah, you got it. So it automatically mounted the file system. So from here, if I say mmlsnsd, so you can see that there are two disks in the file system, and mmlsfs db2fs, right? So that's the file system. So you can see the things, and if you say now df, you will be able to see that. So from the client node, you are able to access that particular file system. So you can see that, and you should be able to create some file, and that file should be visible here also, /gpfs/db2fs, and you can see that it is visible here also. Okay, so this is very simple. So these are all the commands. So all you need to create is a cluster and accept the license, get the cluster state, prepare the disks, create the NSDs, right, and create the file system and mount the file system, and if required you can start up and shut down the GPFS daemons. Now if you want to delete, you need to do the same thing. So unmount the file system on both the nodes. So this is the procedure for deleting. So mount the file system name, and it is better to do it on both the nodes. Okay, so I have to go to cd/user lpp mmfs/bin, and I'll have to say /. So I'm going to unmount the dev file system from here. Okay, so the same thing I'm going to do here also. Okay, so obviously user/lpp/mmfs/bin. Okay, and unmount the file system from here also. So if you look at df, it's not there. If you look at df, it's not there, so it's unmounted. Then delete the file system. So once you delete the file system, okay, so all data will be destroyed, yes, which is what we want. So mmlsfs db2fs, that's not there, so we have deleted it, and still the disk will be there, NSD will be there, so you can check that. So it has become free disk, so it's not part of any file system. And you can delete the NSD using a single command like this. So once you delete the NSDs, that will also be like, removed. Like if I say mmlsnsd, nothing is there. So I can do the same thing here also, /mmlsnsd, nothing is there. Okay, no disk is found. So once that is done, I'll shut down the GPFS daemons on the client node. Okay, so this is where the client node. So I'm going to shut down the daemon. I'm going to now delete the cluster. So if I want to delete the cluster, I'm going to delete the node with the client node first. Okay, I'm just going to demonstrate how to delete the client node, and then I'm going to issue del node the node name. Okay, this will be done on this. So this shutdown is done on the client node, and the deletion of the client node is done from the server node. Okay. Okay, command successfully completed. So I'll shut down the daemon on the server node also now, because I don't want that also. So I'm going to completely remove the cluster. So I'm going to say yes. I mean, I'm not going to restart the daemon in any case. So I'm just going to issue this del node command. So that should delete the cluster altogether. Like, okay, so del node GPFS1. That's it. So if I say now mmls cluster, whoop, I think it's an asynchronous process, so it's taking it's taking a bit of time. So mmls cluster. So is this part of a cluster? No. And is this part of a cluster? Nope. That's it. We are done. So we have created the cluster, we have deleted the cluster, and these are the steps for it. So how to create the cluster, how to delete the cluster, how to create the NSDs, how to configure the NSDs, how to create file system, how to delete file system. So everything we have seen in terms of commands, and various configurations are possible, and I'm not going to get into all of that. So thanks for watching my video. See you in the next video tutorial. Until then, bye bye.